In this video, I'm going to talk about U-substitution and provide 2 examples. Let's get started. The first thing that people usually ask is, how do I know I have to use U-substitution? So if you have something of this form, then it is usually a good indication that you can use U-substitution. And sometimes this can be pretty hard to visualize what's going on, so the best way to explain it is to use an example. So let's say you have something like this. Ln x squared 2x dx. Now referring back to this right here, the ln is our particular function, and x squared is our other function, that's our g of x. And the derivative of x squared is 2x. In other words, it's g prime of x. Then you have your dx, and now that's your integral. And so how does U-substitution play a role in all of this? So let's say I set my g of x to equal u. And in my case, my u is x squared. Now, g prime of x is the derivative of u. U is x squared, and the derivative of x squared is 2x. So the derivative of u with respect to x, we can also write that just as du dx, which is 2x. Now, what does that mean for our equation right here? So this can actually be written as ln of x squared was u, right? So x squared was actually u, and then 2x is du dx. And then don't forget this dx that was left over. So we can actually cancel those dx's out, and you're left with ln u du. So this becomes what you're trying to solve. And in general then, if we have this, we can just write this as f of u du. And that's kind of the goal of U-substitution. You are trying to solve a much easier integral than you had in the beginning. Okay? So that's just a super brief intro. Let's do an example. So this is a rather simple example. Let's say you have x plus 1 squared dx. And you might be thinking, well, this is not written in the form that we desire, right? The form we just talked about. But it actually is. And let me show you how it's written in this form. So notice how x plus 1 is squared, right? So f can be the function that squares things. So we can take f of x plus 1. And that would just mean that it's going to square it. But that's still not in our form. Furthermore, we can say that x plus 1 is our g of x. And so what's the derivative of x plus 1? It's just 1. So g prime of x is just 1. So it doesn't matter. It's not going to change our integral. We can multiply it by g prime of x. So now we have it in that form. So let's move on to the U-substitution. So u is equal to x plus 1. And the derivative of u with respect to x is just equal to 1. Okay? So we're going to take f of, and notice that f of u is going to be u squared. Okay? So now we go back and we say we have u squared, and we're going to multiply that by du dx. And we have this dx right here. Those will cancel out, and you're left with u squared du. And we know that the integral of what the integral of that is. It's a much easier integral. That is just going to be 1 over 3 u cubed plus a constant. And all you have to do now is sub in your u value back in. So you get your final answer. 1 over 3 x plus 1 cubed plus c. So we're going to move on to a more difficult example. So let's say we had x squared plus 1 dx. This example is a great way to show that not every integral is going to be laid out in the perfect form to write out U-substitution. Sometimes you have to manipulate your function so it works out. And what I mean by that is, let us first kind of start by writing this as 1 x squared plus 1 times x dx. And I'm going to say my f of g of x function just takes the reciprocal of g of x. Okay, and in this way, I can kind of see, well, let me set g of x equal to x squared plus 1. But this is where the problem occurs. If I take the derivative of g of x, I get 2x. But I have an x here, not a 2 of x. So if I were to put this in this form, I wouldn't get this integral. But there's a way I can get this integral, and that is if I divide by 2 in front of the integral. Okay, so let me write it out now. So I'll take f of g of x, g prime of x, dx. So if I have a half here, my f of g of x is just going to be 1 over x squared plus 1 multiplied by 2x. And those 2's will actually cancel out, and I'll be left with x squared plus 1 dx, and I'm good to go. So it works out in this way. So let us get started with the U-substitution then. So let u equal x squared plus 1. d of u dx is going to be 2x. And then our f of u is going to be 1 over u. And so don't forget the half, right? So we have the half 1 over u du dx. Those cancel out. You're left with a half 1 over u du. And then that's just equal to ln of u plus constant. And now all you have to do is sub that u back in. So you get a half ln x squared plus 1 plus your constant. And that is your final answer. So that concludes the video. I really hope it was helpful, but you'll have to do practice problems yourselves to truly understand the material. Thank you so much for watching. I hope you guys have a great day.